Okay, so we have another question from exercise 1.1, question number 5, and we given some expression like this. How we can we solve this? So first step here, what should be our first step? So first step should be to convert it into power, right? First step is to convert into power, right? So first what we'll do, we'll convert this into power. Let's convert that. So this can be written as 3 over 5. Now this is cube root, so we can say this is 1 by 3. And here we have power 5, sorry. We have power 5. So I'll write that expression inside part as 2x square minus 7x minus 5 raised to 5. And this entire term is power to 1 by 3 since we have this cube root. We have 1 over cube root of a raised to 5. So what we can say? We can say this is nothing but a raised to 5 by 3, right? Since this cube root will change into 1 by 3. So they're applying the same thing here. So this becomes 3 over fifth root of 2x square minus 7x minus 5 raised to 5 by 3. Great. So now one part is done, but we don't want our term into denominator, right? We don't want our term into be in denominator. Here it is not recommended. Why it is not recommended? Because we have to apply unnecessarily 1 over u differentiation. We need to apply 1 over u, so that will give extra strain or extra steps to calculate it. So first we'll shift this into upper side, and then we'll apply our formula x raised to n. Okay, so let's do that. So this can be written as 3 times 2x square minus 7x minus 5 raised to minus 5 by 3 over 5, right? Wow, how I did that? So that's a simple, again indices, 1 over a raised to m is a raised to minus m, and that is what we did here. Great. So now we have our function, so we can call this as y equals to 3 by 5 2x square minus 7x minus 5 raised to minus 5 by 3. So this is a simple function to differentiate, right? We have inside function, and then this function is enclosed in another power function. So we know what is the differentiation of power function. What is differentiation of power function? So that is nothing but differentiation of x raised to n, which is n times x raised to n minus 1. So let's start differentiating this function. Okay, so in the left hand side we'll have y dash, and the right hand side, since 3 by 5 is constant, so it will remain as it is, and we just need to differentiate 2x square minus 7x minus 5 raised to minus 5 by 3. Okay, so what should be our solution here? What should be our solution? So 3 by 5 will remain as it is. So what will be our solution? If you see, this is inside function, which is our x. We have power, which is our constant. So we can say our differentiation will be minus 5 by 3 into x, which is 2x square minus 7x minus 5 raised to n minus 1, right? So that's a differentiation of this bigger part, which is power n, but we need to differentiate this inside part also. We need to differentiate this part also. So differentiation of 2x square minus 7x minus 5, and this should give our final result, right? So let's write our final result. So if you see, this get cancelled, this get cancelled, so you are left with minus 1 over here. 2x square minus 7x minus 5 raised to, what will be minus 5 by 3 minus 1? So that will be minus 8 by 3 into. Now since these terms are in subtraction, so we can directly differentiate, because differentiation is a linear operator. Linear operator means it can go inside a function if they are in plus and minus. Okay, so what will be differentiation of 2x square? So 2x square, 2 will remain as it is. Differentiation of x square using our power differentiation is 2x minus 7 will remain as it is. Differentiation of x is 1, so into 1 minus 5. Now since 5 is alone without any variable, its differentiation will be 0. Okay, so just remember this: whenever you have constant with some variable, it remains as it is, but when we have constant without variable, its differentiation becomes 0. Okay, so let's write our final answer. So this is minus 2x square minus 7x minus 5 raised to minus 8 by 3. This becomes 4x, this becomes minus 7. So this is our y dash, or we can call it dy by dx.